We have been discussing so many topics in organic chemistry. Already discussed conversion, distinctions, and reaction mechanism. But today we are going to discuss very important part of organic chemistry, that is name reactions. Some organic reaction synthesis that discovered by different scientists. On the basis of their discovery, the importance of reaction, the reaction is named as name reaction on the basis of their name. So, and why it is important? This is very important conversion, that how to convert one particular functional group to another functional group using particular reagent, and with system that would be appropriate methods and conditions. And it is highly essential in organic synthesis. For our synthesis of organic compounds, that for higher member long chain organic compounds having more than one functional group, we have to use different name reaction for the synthesis. You have to introduce different functional group in organic compounds. So let us discuss different name reactions in alphabetically order, starting from A. Okay. First name reaction is aldol condensation. Aldol condensation, it is that condensation reaction of aldehyde or ketone having alpha hydrogen atom reacts with dilute alkali NaOH or KOH, forming beta hydroxy aldehyde or ketone. This is the main theme of the aldol condensation. For example, you take that acetaldehyde. This is acetaldehyde. You can write ethanol. Ethanol, when react with another ethanol in presence of dilute alkali, dilute NaOH, and forming, when two molecules combine, condense, it produces like this CH3, CHOH, CHO become OH, and that H obtained from second one, so remaining CH2, CH2. This is the technique. First, same compound will be repeated, CH3, CH, O become OH, and that H from here, so remaining CH2, CH2. And mechanism already we discussed. So this is called, if numbering 1, 2, 3, 4, beta hydroxy aldehyde, that is called, beta means 3-hydroxy butanol. 3-hydroxy butanol. This is called aldol condensation. Conversion of aldehyde or ketone having alpha hydrogen atom. This is alpha. Having alpha hydrogen atom forming beta hydroxy butanol or aldehyde or ketone. That is called aldol condensation. Another important thing is, second part of this is, one example I will give you. I will not give you detail more than one. So any question you will ask, you write one examples. That how the compound is converted to another compound having different functional groups and using particular reagent. That is called name reaction. Here first one is aldol condensation. This is called aldol because having aldehyde group on all, that is aldol. Here cross aldol condensation. Cross aldol condensation. What is cross aldol condensation? Here different group will be taken. For example, you take CH3 CHO plus HCHO. Different group will combine. That is called cross aldol. Same sodium hydroxide, dilute medium, then product. Here which will give hydrogen? You have to see. As it has no alpha hydrogen atom, so it has alpha hydrogen atom. So first you have to take this one. CH2, O become OH, CH2O become OH and it is losing hydrogen. So remaining is CH2 CHO. This is the main product of this. That is name is 1, 2, 3 hydroxy propanol. Here it is a cross aldol condensation because different aldehyde combined. One having alpha hydrogen atom, here having no alpha. This is ethanol combination. Here ethanol with methanol. That is formaldehyde. Forming 3-hydroxypropanol. Here 2 carbon, 1 carbon combined having producing 3 carbon. This is called cross aldol condensation. Then number 3, that one is also important. That is Ball-Schwarz reaction. Ball-Schwarz reaction. We are writing alphabetical order. Here Ball-Schwarz reaction is main important thing is that diazonium salt BDC N2 plus Cl minus, that is BDC. BDC in presence of HBA4. That is, what is this called? Fluoro. That is called fluoroboric acid. Fluoroboric HBO4 on heating produce. First product is like this. Here that N2 plus BA4 minus substitution reaction. Then on heating produce fluorobenzene plus nitrogen plus butane. That is called fluorobenzene. Fluorobenzene, that is your BDC. What is BDC? Benzene diazonium chloride. So this reaction is called Ball-Schwarz reaction. Formation of diazonium salt to fluorobenzene, and it is specific only preparation of fluorocompounds, fluorobenzene. That is called Ball-Schwarz reaction. Okay. Then number 4, Biwott-Blank reaction. Biwott-Blank reaction. What is that? Biwott-Blank reaction is a simply reduction of any aldehyde or ketone. Any aldehyde when reduced by hydrogen, but not direct, indirect reduction using sodium and alcohol, ROH. It produces hydrogen indirectly. Sodium alcohol produce hydrogen gas. That alcohol hydrogen will reduce aldehyde to alcohol. This is your alcohol. This is your aldehyde. Ketone also. Example, ketone also can be used. Produce alcohol. This is called Biwott-Blank reductions. Conversion of aldehyde ketone to alcohol using sodium and ethanol. So this reaction is called, just already you know this process, this reaction already you have read, but the name you don't know. But you have to write, you have to remember this name, Biwott-Blank reductions. That is called reduction of aldehyde and ketone to alcohol. Okay. Then number 5, that is Kenny-Jaros reaction. In Cannizzaro reaction, already we have already discussed that aldehyde or ketone having no alpha hydrogen atom reacts with concentrated alkali forming alcohol and carboxylic acid. You take one aldehyde having no alpha hydrogen atom, that is formaldehyde, as methanol. React with another methanol in presence of concentrated sodium hydroxide. One will be reduced to alcohol and other will be oxidized to acid. As is a basic medium, so product will be salt. Instead of acid, the product will be salt. This reaction, this is methanol and this is sodium formate. Always remember, when you are writing any organic reaction, you have to write the equation with name. Formula name you have to write. Don't forget this one. Then if you forget to write the names, then you lose the marks. That compound you are writing in the reactant side and the product side, you have to write the name under the compound. You have to remember these rules. That here methanol in presence of alkali, concentrated alkali, one is gets. And Cannizzaro reaction is called also disproportion reaction because one compound gets oxidized and reduced. Reduction and oxidation of the same compound. That's what it is called what? Cannizzaro reaction. And here there is also important cross Cannizzaro reaction. In case of cross Cannizzaro reaction, what happens? If any different aldehyde, for example, you take this aldehyde, it has no alpha hydrogen atom, reacts with another aldehyde, that is formaldehyde, having no alpha hydrogen atom in presence of base. Here what happens? Which will be reduced, which will be oxidized. Here, as just you see, as it is a cross effect, so this compound, the concentration of the electron density of oxygen will be more. So first it will be, what happens? It will be reduced to alcohol. This is your alcohol product. CH2OH, that is alcohol, and remaining will be acid. So this is very important. This is para-methoxy benzaldehyde, and this is your methanol and producing para-methoxy benzyl alcohol and sodium formate. This is your benzyl alcohol, para-methoxy benzyl alcohol, and this is sodium formate. So you will write this thing. These two names also you write down. So this is called cross Cannizzaro reaction. Cross means different aldehyde having no alpha hydrogen atom when combined, that is called cross Cannizzaro reaction. And cross aldol condensation where different aldehyde having no alpha hydrogen atom, one having alpha hydrogen atom, another having no alpha hydrogen atom, or both having alpha hydrogen atom can combine to form what? Aldehyde, and that beta hydroxy aldehyde or ketone. It depends upon the reactant taken. So this is called cross aldol condensation. Then carbylamine reaction. Here only that primary amine, any primary amine when reacts with chloroform in presence of base NaOH produce what? Isocyanide, RNC plus NaCl plus water. This is the reaction. Here what happens? And the reaction takes place on heating. On heating. So this is your primary amine. That is depends on methyl you can get chloroform and NOH produce carbylamine. This is called carbylamine or isocyanide, and it is obtained as a foul smelling gas. This reaction is called carbylamine reaction. Only it is shown by primary what? Primary amine. And your aniline also gives this reaction. Aniline also gives this reaction CH3 and NOH or KOH. On heating, the result is isocyanide. This is called your benzonitrile. This is called aniline. This is benzonitrile, and this is your aniline. So this reaction is called carbylamine reaction. Okay, then you complete this one, then you start the next remaining reactions. Okay, Clemmensen reduction. In Clemmensen reduction, what happened? This aldehyde gets reduced in presence of zinc amalgam and concentration on heating produce alkane. This is very important. This is your aldehyde. Aldehyde or ketone, not only aldehyde. Aldehyde or ketone will be reduced by zinc amalgam and a concentrated HCl. On heating, the product is alkane. This reaction is called Clemmensen reductions. Okay. Then that is next one is coupling reaction. In coupling reaction, that here diazonium salt that is BDC in presence of phenol and on heating the result is this is called azobenzene. What is para-hydroxy azobenzene? Para-hydroxy azobenzene, and this is orange dye. Orange color dye is produced. This is your phenol, and this reaction also shown by aniline also. Then same BDC plus aniline on heating produce this type of compound. Para-amino azobenzene. Here, this is yellow color dye. This is the difference between that aniline, this is aniline and phenol. Okay. Then coupling reaction 9, then 10, that is Claisen condensation. And this reaction only for condensation of ester. Already we have discussed condensation of aldehyde, condensation of ketone in case of aldol condensation. Here just similar type, but here condensation between ester. If you take CH3 COOC2H5 plus another CH3 COOC2H5 in presence of sodium ethoxide, base acts as a base, not nucleophile, acts as a base. Yes, C2H5O minus acts as a base. Then the production condensed product will be CH3CO. Then it will act as CH2COO C2H5 with the loss of C2H5. Product is C2H5, remaining product is C2H5OH, alcohol. And here ethyl acetate, and in presence that is produced, that is alpha, this is beta keto ester. Generally, but the naming, if you give the name 1, 2, 3, 4, that is 3 oxo, then ethyl 3 oxo or 3 keto, 1, 2, 3, 4, that is butanoate, that is your IPC name, but generally it is called beta keto ester. Conversion of ethyl acetate to beta keto ester, that is conversion of ester to beta keto ester. Remember this thing. This condensation is called Claisen condensation. This takes place in presence of ethyl sodium ethoxide, that is acts as a base. So this is called Claisen condensation. Then another one is Claisen reaction, or it is called Claisen steamed reaction, or it is called Claisen, it is also called as Claisen steamed reaction. In case of Claisen steamed reaction, what happens? Just here benzaldehyde C6H5CHO in presence of acetaldehyde and alkali, same, just aldol condensation but specific. Here product will be, what happens? C6H5CHOH CH2CHO, then on heating the product will be C6H5CH, here water will move CH and CHO. This is called cinnamaldehyde. This is called cinnamaldehyde. Conversion of benzaldehyde, or benzaldehyde reacts with acetaldehyde in presence of base, dilute NaOH forming beta hydroxyaldehyde, and that beta hydroxyaldehyde on heating produce lost water, loses water molecule and forming unsaturated aldehyde, that is called cinnamaldehyde. This reaction is called Claisen reaction or Clemmensen reduction. Okay. Then next one is very important reaction, that is a decarboxylation. Decarboxylation generally takes place in presence of heat, when salt of acid sodium salt or acid when heated in presence of soda lime, calcium oxide and sodium oxide on heating produce lower alkane. CH3CON means methane. Lower alkane and remaining product is sodium carbonate. This is your salt, sodium acetate, and this is your benzaldehyde. I have not written benzaldehyde. This is ethanol, and forming beta hydroxy benzaldehyde, beta hydroxyaldehyde, then on loss of water forming cinnamaldehyde. Here sodium acetate reacts with methane, reacts with soda lime forming methane, and this method is always helpful to prepare that lower alkane. Here alkane, that is here 2-member carbon producing lower alkane is methane. So like this is called decarboxylation. Then another very important is, that is, you can say diazotization in the D. Diazotization reaction. In diazotization, what happens? Aniline, any aromatic, mainly aromatic, aniline, this is aniline, when reacts with HNO2, generally HNO2 is not used. Instead of HNO2, because it cannot be stored, we can use sodium nitride and HCl, and this produce BDC, N2 plus Cl minus, N2 plus Cl minus. This is called BDC, benzene diazonium chloride. This reaction at the formation of a diazonium group, azo group is produced. That's why it is called diazonium salt. And this reaction generally takes place at a very low temperature, around 0 degrees Celsius. Around 0 degrees Celsius. At 0 degrees Celsius, this reaction takes place. Very low temperature it takes place, because at a high temperature this BDC is unstable. That's why the reaction takes place in the presence of below low room temperature, that generally 0 degrees Celsius. So this is called diazotization. In the next class, we will discuss remaining other name reactions. Okay, you practice. Any doubt, you can ask me. Okay, thank you all.